Alison, and thank you so much for accepting to do this interview. Very excited to have you here and meeting you after such a long time. And I'm sure everybody is waiting to hear what you have to say. So let's just start the questions. And I will start by just asking about how your data science journey, in a sense, began. Where you started, where are you now? And was there any difficulty along the way for you to get here? And specifically, personally, I'm interested to know if gender played any role in the difficulties, if you had any.
Okay, absolutely. Thank you so much for the invite, and it's a pleasure to talk to you as well. It's a shame that we haven't been able to meet in person, but hopefully next year.
Yeah, sure.
Um, I've always been, since a small child, I've always been very interested in computers. I remember when I was 7, 8 years old, you could get magazines where you could type up computer programs into the computer and run them, or spend most of your time debugging them. So I've always had that interest. I did sciences through school. However, when I first went to university, I did archaeology as a degree and physics. So I had two very different subjects. I was very interested in past societies and how people behaved, but I was also really interested in physics and complexity and nonlinearity as well. So seemingly quite different areas, but I think have sort of come together in my career. I went to Leeds University, where I am now, and I did a master's in GIS. I also did my PhD there in artificial intelligence. And this is really where sort of my background, the two areas that I've been working in came together, that I was really interested in how people behave and move, but I was also interested in how you would model that. So how would you create a computer system where you could create individuals that move around a geographical area, but also you could simulate their behavior as well and see what happens. So that kind of really brought together two areas that I did for my undergraduate degree into this. I was incredibly lucky at the time, lucky and not, that I was one of the first people to do a PhD in the area of agent-based modeling, which is one of my main areas of expertise. Lucky because that's created me an awful lot of opportunities, which have benefited my career, which I'll come on to. Unlucky in that there really wasn't much published literature around or people working in this area for me to be able to talk to as well. So I think most people at some point in their career feel like they're making it up as they go along. And certainly my PhD was, let's just try some things and see what happens, which, you know, that's what research is about.
Right.
Because I was quite early in the area of agent-based modeling and in geography, I've had a fantastic set of opportunities as well. And because of the funding I had as well, I was able to travel to lots of different conferences, present this new work, and that garnered a lot of interest. So coming to the point about my career and how my journey, I would say that I have been incredibly lucky. I was very early in the agent-based modeling. I was there at the right time. I met a lot of really interesting people who I've established long working relationships with. So as a woman, I would absolutely say that the very first conference I went to, Geocomputation 2003, I think there were 90 men and 3 women. Those proportions have changed, but not
dramatically, yeah. No.
Not at all. If I go to a conference and there's more than, say, another 10 women, it's remarkable in this area. I mean, that's something I can come back to. But I've benefited by where I work in Leeds is a really strong research community. We've built up a lot of people working in the same area. I have some great colleagues who I've written with. And throughout my career, I have 3 children. So I've had 3 periods of not working for 3 years. And the only way that I've managed to sustain my career is by having set up different working relationships with people. But as I say, I think I'm actually an exception to the rule rather than general. So as I said, when I look around at the data science landscape, women are very much underrepresented. And in fact, I would extend that not just to women, but the lack of diversity in this area still is mind-blowing. I mean, my personal experiences are that I'm a professor at my level. I could probably name 1, 2 other female professors at the same level. And I'm thinking over Europe as well, not just in the UK where I'm based. However, if I look at my own department and my own research group, we are really well represented with women at PhD level, at postdoc level. However, when we move into the academic levels, lecturers, it starts getting narrower and narrower. And that's something I think we really need to sort of address. Women are great at coding, we bring a whole set of new skills, but that lack of diversity, certainly at the top of the pyramid, I think it's something that we all need to be thinking about. Why is it there, and what can we all do to try and address that as well?
Yeah, that's totally true. You're going to see more. I mean, still not that many in lower levels of the hierarchy, but the higher you go up, there is some sort of pushback. It's not very explicit, but it is there. That they're just getting cut down. So
yeah, and it's the question is, why is that? I mean, as women, we will, if we have families, we will be the ones who take the time off, naturally so. But where is the level of support to keep women engaged and keep women in the academic careers as well? And I think that's across a lot of the STEM sciences as well. My experience is within computing. And the Alan Turing Institute, where I hold a fellowship at, are trying to do things, introduce fellowships and ways to try and keep women retained in. And I'm talking about women, but of course, a whole range of different diversity indicators as well. But the conferences I go to are 80% white male.
yeah, that's totally true, and that's unfortunate. And I certainly hope, I don't know if it is happening this generation, but this is something that needs to be changed, because we are missing on half of us, really.
Absolutely. And I think there are some structures in it, but you look societally as well. In the UK government, for example, it's mainly white men. Our reaction to the pandemic was a formation of a committee, the SAGE committee. It's 90% white males. So
I think I remember this photo of Margaret Thatcher when she became the prime minister, and the whole government were men, and it was she sitting in the middle, and she even didn't consider having women. Even for her, that was too much.
I know, but now you've got something great like Joe Biden's cabinet is very diverse, female, ethnic minorities, in contrast to Trump's all white, old male, rich cabinet as well. So I think we can be optimistic there are changes there, but certainly within data science, I think there's a lot more that needs to be done. I think just working out why more women aren't involved and how we can get them, put practical steps in to equal the playing field is something that absolutely needs to happen.
Exactly. I was given actually a talk yesterday about this, and I was saying that in the gender equality as a whole, we have moved more forward than in technical fields and data science specifically. We know something is not right, but it doesn't hit us when we go to a conference and see there is few women, and we accepted it as a reality. Somehow it is not in the other fields, but in this one, it is a reality, and we have accepted it. This is something that I think needs to be changed first and foremost.
Absolutely. There was an article, I think, in Nature last week about mentoring, and I think the implication of it was that female mentoring isn't as useful as male mentoring. I can't remember, but I always think mentoring is perhaps one of the ways that we can help, especially women who've got to the top, can help bring other women up as well, sort of smash that glass ceiling. But I mean, I would love to see some strong agenda or something formed to really push, get this noticed and get people on board in the right positions, vice chancellors, whoever, to really help address this and push it. Because I think there's a lot of easy fixes that could be made that could make a real difference.
Yeah. I think at some point we need to stop talking and making some actions, I suppose.
Absolutely.
Yeah. Okay. Let's get to a bit to the scientific part as well. In your research, you're focusing very much on the smart cities.
Yeah.
How do you define the smart city? When I'm telling somebody that the cities of future are going to be smart cities, what is it exactly? And what is the difference between social cities, as you describe them, and smart cities?
Absolutely. I mean, smart cities is one of those buzz phrases. I think that smart cities, future cities, all kind of means the same thing. And the work that we're doing specifically, we're looking at collecting data from environmental sensors, so your traffic sensors, footfall sensors, your social media data as well, such as people tweeting or checking into places, even mobile phone tracking. And the idea is that if you say go to Trafalgar Square in London in the middle of a day, who are those people? Okay, there'll be no one there at the moment. In normal times,
this is what I was thinking. I want to go to Trafalgar Square.
if you know, if you can cast your mind back to how normality was, you know,
Yeah.
there were people there, you know, sort of who are these people? What are they doing there, and where are they going to go? Now, the idea of the smart city work that we're doing is if we can take lots of different types of data together, bring them together, we can deepen our understanding of what people are doing and people's mobility. Now, once you can start building that picture up, you can start asking some really interesting, complicated questions about, so what if in the middle of my city, which has one of the highest air pollution levels in the UK, what if we pedestrianise the middle of the city in the middle of the day? What are the implications for health, our health service in terms of reducing down inpatients? What's the implications economically? What's the impact on transport? So these are very, very tightly interrelated questions. Now, the way we see smart cities are, how can we take this data and all these new technologies that are rapidly becoming available to us, the Internet of Things, people carry around these mobile phone data, you know, most people have these smart watches as well. How can we take all this type of data and do something useful with it to make the cities work for us? Can we make the cities a more pleasant place for us as human beings? Can we adjust people's behaviour? Can we make that transition from people driving into work on their cars to moving to bikes or other forms of transport? What needs to be done? Can we do simple things like, can we make the traffic lights work in a more efficient way to minimise traffic jams, congestion? Can we have smart buildings where we control the temperature or the air conditioning based on occupancy? I think the smart city agenda is not only just understanding how people move around cities and how we can improve that, but it's also about how can we make the cities more sustainable? How can we make them more livable for us in the future? And I think underlying that as well, the part I'm interested in is how can we adjust people's behaviours? So, you know, the bike example is a really good one. How can we get people doing smarter transportation, which at the moment, there's a great incentive in the UK and money going into that because of the pandemic. We're discouraged from using public transport and instead we're encouraged to take up bike journeys. And I think in the UK, 80% of journeys are sort of 3 miles, sort of 5 kilometres.
Right.
So can we transition people's behaviour? And sort of related to that as well is, if there is a major incident in a city, if the main transport hub is taken out, what are people going to do? How are people going to react as well? And can we use all this sort of data we've got and machine learning methods to really understand what people are going to do in different types of situations as well? And that's both in real time as well as using it as a tool for planning ahead into the future as well. The final thing I would say with that is the other term at the moment that is getting a lot of traction, particularly in the UK, is digital twins.
Right.
And again, that's a phrase where I think engineering has a very set definition of it, the social sciences do, but we are, with the work that I'm involved in with the Alan Turing Institute, we're looking at building a digital representation of the UK. So this will be how the main processes that cities operate. And if we've got this digital twin, it's almost like a little Sim City toolbox. We can play around with different factors to try and improve the infrastructure of the cities, perhaps, you know, how goods are transported between cities to help the economy, and how people move and, you know, go around cities as well. And I think that with the current pandemic has become much more prominent. You know, what can we do immediately inside our cities so people can move around them, but safely as well?
Yeah, I mean, I think this is really a major project, and this is very interesting and important. At the same time, you talked about collecting the data.
Yes.
I mean, having all these sorts of data, and that, in a sense, is an issue because we are collecting the people's data. And how do we develop this trust in people that this is fine, that we are collecting your data and we're processing it?
Yeah.
Where do we? Because already I hear a lot people are afraid of, although they are contributing with their data without being conscious about it, but how could we put them in ease that that's fine?
Yeah, absolutely. I mean, the dream would be to have individual level data for everybody all the time. However, the reality is that that shouldn't happen. And I mean, certainly, I think there's two parts to this question. One is the ethics side, and absolutely, as academics, we have to respect people's privacy, and their information is their own. So I think, you know, I would assure you that, and I'm sure you do the same, that we have a very, very strict code of conduct in terms of ethics and the data that we're allowed to have where I work at the University of Leeds and at the Alan Turing Institute, there are safe areas. You basically are locked into a little box, safe rooms to work on individual level data. And it's very, very tightly restricted, as it should be. The second part to that question, which I think I might have just forgotten what I was going to say.
Basically, the question is that, is it communicated with the society? Like, do
Yes.
they know that this is safe?
So I think the key part to this question is exactly what you just said: communication to the public. This is your data. This is how it's used, and this is why we're using it. And with a strong undercurrent of, this is not what we're doing. We're not spying. We're not stalking on anybody. And I think people are naturally always going to be very reticent and perhaps suspicious that data is going to be used in a underhand way, or they're going to be looked at individually. And I think we have to reassure the public that data, a lot of data we play with is at the aggregate level. So it's rare that we get that individual level data, or something's performed with the data to stop us being able to identify individuals. It's one of the projects I'm working with the Alan Turing is looking at creating synthetic versions of really sensitive data sets. And part of that project is, so for example, health data, it'd be really useful to have, and we have hospital records. Can we recreate that data set, but can we, keeping all the important relationships in that as researchers we want to investigate, but can we maintain the privacy of the individual so nobody can be recognized? And so that data can be used in a synthetic version, but people's privacy is maintained. And that's something we're developing with the Alan Turing at the moment, that, health data is one application, but financial data, other data sources that researchers really want to get your hands on to play around with to further the work. But necessarily, people's privacy and ethics, there are restrictions there as well. But I think it's about building trust. I think, unfortunately, Cambridge Analytica, Facebook, there's been a number of scandals in the last few years where people's data has either been stolen or taken without their knowledge. I think it's a trust building exercise with the general public, and reassurance, and showing that we're very transparent in the measures we're taking to safeguard the data, and particularly what are we using it for and what's the benefit as well. I think that's the key to this.
Yeah, definitely. And by having that in mind, so the cities of future, the smart cities of future, are going to control our lives or going to make the world a better place to live in?
Both, surely, both. I mean, I think that the whole,
There's a trade-off.
there is, but what is that trade-off? What point, as researchers, I work in research because I want to do things that are going to be of benefit to people as well. And you're absolutely right. There is a trade-off. I mean, what's the broader question here?
So let me elaborate on that. We all are brought up in the era that it was full of sci-fi movies, that the robots are going to take control. The cities, the main AI thing somewhere is going to take control. So this is some sort of hidden fear. That is it what's going to happen? They are getting so smart that they will dictate the way of our living, or no, they are just there to make the world a better place to live in.
My first comment would be, I think a fairly dumb robot would do a better job than perhaps some of the politicians in my country, but
in many countries, to be honest.
Do you know what? I think, one of the things I was reading a few days ago was, at the moment, so I have a smartphone that shows me my health data. I have an app I can log on to that I can say what I've eaten. These things are coming further and further together now. In that regards, I wouldn't mind having all my health data and everything put together for my benefit, but that's my choice. So again, it comes back to what the choice is. I think if we can use AI to, if suddenly a station closes down or some transport hub or something happens, and AI can be used to circumvent all the problems, come up with a solution in real time, fantastic. If we have another epidemic of any sort, pandemic, if AI can be used to identify patterns of behavior or people who are at risk and be useful to us, then absolutely. I think there is potentially a massive benefit to using AI, data science, machine learning, whichever term you want to give it. Again, it comes back to the point we've just made. It's about communicating to people, because I think there's a lot of I don't want to say ignorance, but I think there's a lot of misunderstanding about these
Yeah.
methods, actually how clever they are. A lot of the time, you have a human behind them. And, you see things like AI generated news articles, this story, but people then interpret it. It's a human who interprets it. Machine puts down the words. It's us who give those words meaning. So I think again, it's all back down to communicating, being transparent in what we're doing. And AI is not a new thing. Perhaps it's come to prominence recently, but we've had sort of algorithms working on large data sets for years. It's just now that because we've got better computer power, we've got lots of data, it's having its moment, and it will continue to do so as well. So I think part of me is let's accept we have this in our lives, but let's accept it's going to be of use to us, and let's use it in that way. Now, I think there are areas in science where people are worried that AI is going to step over the line, but I think the sort of idea that we're going to have robots telling us, 20 press ups, don't eat that donut. I think we're a little way, well, maybe these smart apps will do that, but I think we're a little way off the point where the robots will rise. I think we're at a unique point where in medical science, you're seeing all this fantastic work where AI and algorithms can look at data and help with diagnosis. These are the things that we should be excited about.
And I think I'm totally with you on that, because they are very useful, and they definitely are going to make our lives a better version of it. But the fact is that, as we said, it's a communication problem, and the people who are in charge of the communication, the media, are focusing on the side that sometimes even don't exist. And now we have these expectations from AI as general to be better than us, to make better decisions. I mean, we have so many accidents when we human beings are involved in something, but as soon as something developed by AI make a small mistake, it's going all over the news that it is not working, it is not safe. But the fact is that these are not better than us. These are developed based on our data.
Yeah, well, I think, that exactly what you've just said makes a much better news story than, oh, look how great this is. These are sort of like fairly standard.
boring. Yeah.
People don't want to hear that. You can put a nice picture of a Terminator in and then a little robot. Again, it's communication. And unfortunately, the media can be fantastic. But, I think as we've probably seen in the last sort of few years, news story, things like Twitter as well, stories can perpetuate really quickly. And I think that's where institutions such as the Alan Turing Institute in the UK, which is the UK's National Centre for Data Science, are really important in putting out clear messages, engaging the public through different mechanisms, bringing people in. Yesterday, the Turing had an all-day COVID meeting where they had different experts talking about different aspects of COVID. It was available on YouTube, so anybody could watch it. So I think opening up, getting trusted places, opening up the discussion and getting people engaged, and somewhat educating the general public as well to identify what is just an exciting news story, or a clickbait headline, and what actually is going on is really important. I don't think we're ever going to do it, because it's the whole area of AI is such a loaded term. Exactly what you said with Blade, from Blade Runner, Star Wars, the Terminator. People are always going to have these preconceptions, but I think it's presenting, this is what the benefit is to you. This is being done by this mechanism, and being really open and transparent and getting people to communicate very, very clearly with the public is absolutely key.
Thank you very much. So now if one of the students want to follow the footstep and get into being part of the developing the cities of futures, developing the smart cities, what skills do they require, and how they need to prepare themselves for that?
I think curiosity. The one thing anyone needs going into research of any area is a healthy amount of curiosity and a willingness to ask questions, a willingness to read articles and question. Just because it's published doesn't mean it's right. That's the absolute first thing. Someone who's willing to push boundaries and ask difficult questions. More pragmatically, I think because the area of data science now is about skills rather than application area, I would absolutely physics background, maths, coding are probably the three areas I think are probably the core skills in there as well. Saying that, if somebody is doing a geography degree or doing modules on urban development, There's absolutely no, there's lots of mechanisms to get into data science and into looking at cities of the future. It's not just about coding up models. There's a whole area of talking to people, relationships with stakeholders. I mean, that's something we haven't really touched on, but how can this area actually develop into policy? And there's very few people who are really good at taking the results from academia and going over to stakeholders and saying, this is what this model means, this is what you need to do. That is incredibly, again, it's communication, incredibly important as well. So I would say, probably from my perspective, I would always be looking to hire people with a physics, maths, computing background. However, there are so many careers related in this area as well that I've hired people with different backgrounds to work here. Learning the skills is much more accessible now than it was, say, 10, 15 years ago. So I would come back to, I would want to hire someone with curiosity, drive, and a willingness to ask difficult questions.
Yeah, thank you. That was perfect, and thank you very much for your time. We promise to keep it short, and I can talk for ages, but let's stop here. And do you have any final word of wisdom for the students who are listening?
The wisdom.
Yeah.
I think pursue your passions and keep curious, and don't let anyone tell you that you cannot do what you want to do. If you want to be a professor of computer science, artificial intelligence, whatever your background is, you absolutely can do it. The opportunities are there. The key is being brave enough to go and seize them.
Thank you very much. And thank you very much for your time. It was a very interesting discussion. And there are so many things that now the people who listen to you are going to think about and ponder about it. Thank you very much. Have a nice day.
Thank you very much. It's a pleasure.